Welcome back, folks. In the last video, we talked about Ohm's law and how the current across this LED is much more than the current across this one because of these resistors, and hence the LEDs are lighting up much dimmer in this case versus much brighter in this case because there's more current passing through this. But there's another phenomena that's going on in this circuit, and that, my friends, is called potential drop. This is one of the most important principles that you guys will need to know as you're building on your electronic circuits for your final projects or in general while building other new exciting projects. Because a lot of times you'll be building circuits which will require components that require a different amount of voltage to glow versus the power supply that you have. This is very, very key in understanding what the principle of potential drop means. So let's look at it once again. So I'm going to put my multimeter back over here, and I want you guys to follow along and test this on your own circuits. And I'm going to check now on the voltage DC section, again at 20 volts, and I'm going to check the voltage across this LED. And as I can see that the potential or the voltage across this LED is roughly about 2 volts. Now I'm going to do the same for the other LED. What do you guys think is going to be the voltage across this LED? Okay, maybe some of you guessed it right. Let's check. And as we can see, it's much lower or a little lower, 1.73. So there is a drop of approximately 0.25 volts in this circuit versus this one, because these resistors over here are creating that voltage drop. And you can see that they have some voltage drop being created somewhere over there, but it's a little all over the place because the circuit is complex. There is a voltage drop that's happening across these resistors, and hence this LED is lighting up dimmer, creating a different voltage across this. This is called a potential drop. Now, when would you need this? Okay, just think about it for a second. If you have a larger power source, now I'm going to introduce you to a 9-volt battery instead of a 3-volt battery. This one has only 3 volts. These LEDs are rated for 3 volts. So hence, even if I connect them directly, nothing happens and they just light up really, really bright. But what happens if I connect a 9-volt battery to this? Okay, we're going to make some fireworks over here. Hopefully not. I'm going to try and show you this. I'm going to take out this LED and I'm going to connect this to the positive and to the negative terminal directly. Okay? And what do you think is going to happen? It's going to blow up? I think so. Let's try. Okay, I'm going to make you guys see this. So if you can see this very carefully, and we might see a little spark, and whoop! Did you see that? It lit up for a microsecond and then it turned off. Now I'm going to try and put this back on this circuit and see what happens. Boop, boop, boop. Nothing. This LED, my friends, has been fried. And that's how you create an explosion in LEDs, by powering it up with too much voltage. Now you don't want to do this to your circuits. This is how you exactly fry your circuits, by applying too much voltage or giving it the wrong kind of current and things like that. So this battery is no longer going to be functional. So there goes in the trash. Now there is a specific amount of resistors if I put next to this battery, I should be able to light it up safely. Do you want to guess how much that is? Why don't you try do the math? I'll do the math as well on my piece of paper, and I'll share with you in the next video exactly how much resistors we need to be able to light up the LED with a 9-volt battery. Okay, good luck.